Okay, this lesson is mostly review. It's stuff we've done a lot of already, but it's really important. I want to go through finding the equation of a line, so that's why it's called determining the equation of lines, given different pieces of information. So we've already done lessons on this, but I want to do one more final summary, because if you said, what's the most important thing I need to know going into grade 10, that's new that we learned this year, I would say this kind of stuff, finding the equation of a line. Okay, so we're going to go through one at a time, a whole bunch of different questions. And when you do the homework, pay attention, because the questions I'm assigning you in the homework are basically in the same order that's going on here. So you should be able to kind of follow along and solve the questions using similar steps. Okay, so remember, to find the equation of a line other than special cases, and we're going to come across some of those, okay, and we'll review how do we identify those. We're looking for two things. We need the slope, which is m, and we need to find the y-intercept, which is b. Now, we want to try and do this without graphing. Obviously, we could plot this point on a graph, use the slope, the rise and run to try and find out what b is, but we're trying to do it a quicker way. So I'm going to go through these as quick as I can, and because you can probably pause and go back and watch them again, okay? So here we go. So remember, we start with y equals mx plus b. All right, so what's the first thing I notice? Well, they gave me the slope, right? The slope is -3. So why don't we take y equals mx plus b and replace m with -3. All right, what's the last thing we need to solve for? The b, right? What's b? That's what we're looking for right here. So to do that, all we're going to do, if we're given a point, and that's basically most questions, we have to be given the slope and a point or 2 points. Okay, so they gave us slope and a point in this one. So what are we going to do? We're going to sub in that point, substitute. When I say sub, short for substitute. So substitute in 5, -1. So this is the x coordinate, the y coordinate, and then we solve for b. All right, so -1 equals -3 times 5 plus b. -1 equals -15 plus b. All right, we're going to add 15 to both sides, so -1 plus 15 equals b. So in this case, b is 14. So there we go. There's b. So we found the two critical pieces of information. So to write our final equation, right, we just take y equals mx plus b, and we're going to replace the m with the slope. We're going to replace the b with the y-intercept. So our final equation is y equals -3x plus 14. So there's your most simple basic finding equation, given slope and a point. All right, let's try another one. Okay, in example B, notice it's the same scenario. We're given the slope and we're given a point. So right off the bat, we already know our slope is 3/5. They gave that to us. The only difference here is the slope's a fraction, right? So what are we going to do? We're going to sub in the slope, and we're going to place x and y in the equation y equals mx plus b with the point they gave us. So here we go. I'm going to start by substituting in my slope first, right? And we want to substitute in the point. So sub for short, in. And we generally want to state which point we're substituting in, because later we're going to run into ones where there's multiple points. Okay, so we're going to replace x with -20, y with 7. 7 equals 3/5 times -20 plus b. All right, so we can just quickly reduce this and go, all right, 20 divided by 5 is 4. Don't forget there's still a negative there. All right, so now we have 7 equals 3 times -4 is -12 plus b, and add 12 to both sides. 7 plus 12 equals b. b is 19. So that's really the exact same one as before, just with a fraction. I just wanted to show you, hey, don't forget you can reduce. And if you can't reduce, which we'll run into some eventually, you're just going to have to get a common denominator. All right, so let's write our final equation. Replace the m with 3/5, which they gave us, and b is 19. All right, so let's move on to the next one. All right, in example C, once again, they give us the slope. So they save us a lot of work. The slope is 8, so m is 8. But they don't seem to give us a point. They tell us, though, the line passes through the origin. So what's the origin? Remember, that's the point 0, 0. So they did give us a point. Now, you can shortcut this really quickly, but let's say we don't know what the shortcut is, right? What do we normally do? We have to take our equation, y equals mx plus b. We sub in the slope, y equals 8x plus b, and then we sub in the point. So we're going to sub in 0, 0. And some of you might know already, because we've done this quite a bit, right, what we're going to end up getting. So y is 0, 8 times x is 0, plus b. Well, what do you got? 0 equals 0 plus b, so b equals 0. All right, so b is 0. Now, we could have done that right away, because think about if we draw, I'm just going to draw a real quick sketch of a graph here. There we go. It's got a positive slope, right? I'm just going to draw a line. It goes through the origin, right? It looks something kind of like this. This would be my line approximately, right? And it goes through 0, 0. So what's the y-intercept? Remember, the y-intercept is where the line crosses the y-axis. Well, where does it cross the y-axis at, right? This is our y-axis here. I'm drawing these purple arrows on. It crosses at 0. So remember the shortcut, because we're going to run into this in a few questions. And I know I've covered this in previous lessons a few times. Any time that you're given a coordinate where the x, or given a point where the x coordinate is 0, whatever the y coordinate is automatically b. So in this case, x was 0. Whatever this is, it's the origin, y is 0. Because remember, to cross this line, no matter where our line crosses, the x coordinate always has to be 0. So maybe this is 0 over 5 up or something. In this case, if my line went through there, the y-intercept would be 5. Okay, so if you're ever given, last time, a point where the x coordinate is 0, whatever the y coordinate is, that's automatically b. So if you want to skip all this work and just write the answer, this is one I wouldn't expect you to show work. You could just jump to the final answer and go, okay, y equals 8x plus 0, but we don't write that, right? We write this, y just equals 8x. So if we don't see that number behind, we know the y-intercept is 0. Okay, now this one is going to throw you off because everything so far has been pretty reasonable. Now we've seen questions like this before. It says my line is parallel to the y-axis passing through 2, -1. So when I was your age, the first thing I would do is I'd draw a line. Here's my y-axis. Here's my x-axis. Just draw a quick rough sketch. It doesn't have to be fancy, right? The x-coordinate is 2. The y-coordinate is -1. So let's go. We're going 2 over, -1 down. We'll say it's right there, right? 2, -1. Now it says your line is parallel to the y-axis. So I'm going to draw a line that is exactly that, parallel to the y-axis. And it's supposed to go through that point. I've missed it a little bit. We'll just say that's close enough, right? There we go. So this is a horizontal line. So this is, hopefully the bells go off. As soon as you hit a horizontal line or a vertical line, that's a special case, right? So what do we know about special cases? Well, we don't follow the usual thing. We don't use y equals mx plus b, right? That's out the window. Okay, so what do we have to kind of know factually about this special case? Well, we have to know the slope of a vertical line is undefined, right? Because when you do rise over run, we've done this a lot, you get an undefined slope because you'll end up with something like 10 over 0 or 8 over 0 or something over 0, which is undefined. So that's not going to work. Where's the y-intercept of this line? Where does this line cross your y-axis? It doesn't have one, right? So that's why this is a special case. We can't use the usual methods. So we've had to memorize, and we've been through this a lot. So hopefully at this point, this is like your victory lap. You got this down pat. All we do is we just write x equals, for vertical lines, the x coordinate. Where does it pass through? 2. That's it. So if you spotted all that from the start and you thought in your head, you don't have to draw this sketch. The sketch is what I did when I was your age to make sure I understood what I'm looking at. I'm looking at a vertical line. Okay, what do I do for vertical lines? It's always x equals. If it was a horizontal line, which I'm sure we'll encounter in a minute, it would be y equals, the y coordinate. That's it. Okay, I think just like I was saying, we're going to run into another special case here because this line here, it says our line is perpendicular to x equals -7. Well, if there's no y in the equation, there's only an x. This is a special case, and this is a vertical line. Okay, so I'm going to draw another just quick example of this. Vertical, there we go. Just so we can get a visual idea what this looks like. Okay, so let's just draw a quick graph here, and x equals 7, right? Okay, so x equals -7, sorry. So that's going to be a vertical line that crosses the x-axis at -7. And every coordinate on this line, every point on this line has an x-coordinate of 7. So -7 over 0 up, that's where we cross through, right? If you want to pick any point on this line, you know, you could go -7 over 6 up or whatever, right? But the x-coordinate will always be -7. So that's a vertical line. So what kind of line, we got to ask ourselves now, is perpendicular to a vertical line? Well, the answer is a horizontal line. So this our line is horizontal. That's all. So this is more of a thinking question than an algebra or math, you know, where you have to do calculations. This is more, did you memorize the facts? Have you learned the difference between horizontal and vertical lines, right, and what they look like? All right. So what's perpendicular to a vertical line? A horizontal line. How do we write the equation of a horizontal line? We just write y equals the y coordinate, right? Let me just draw a quick sketch of what this might look like. 3 over -10 down. So 3 over, 1, 2, 3. We'll just say -10 somewhere down here, right? There's 3, -10. Well, our line has to be perpendicular to that line. So again, our line has to be, horizontal. I've missed my point again. There we go, right? So these are 90 degrees to each other. They're perpendicular, right? So how do you write the equation of that? You just write y equals the y coordinate. It's just going to be y equals -10. That's it. Now, what can we say about this? What is the slope of a horizontal line? Remember, it's flat ground. It has no steepness. The slope is 0. What's the y-intercept? Well, where would it cross the y-axis at? It would cross at 0, negative 10, because every point on that horizontal line has a y-coordinate of negative 10. So I could write it like this. Now this one you could actually start with the equation like this. You could, let me go over to the side, back over here again. You could go y equals mx plus b, and watch what happens when we sub in slope of 0, 0 times x, and b is negative 10. Well, 0 times x is just 0, right? So it cancels out, and we get y equals negative 10. So again, we've seen this one before. It's just a review, but these are the ones that give people the most frustration and most, confuse them the most. And it takes a lot of practice, not just racing through your homework once, to really master these things for grade 10. All right, let's move on to the next one. Okay, we're back to question F. We're back to like a non-special case line. How do I know it's not a special case? It does say it's perpendicular, but it says it's perpendicular to y equals 4x minus 5. So that's not a special case. It has the y and x, right? It has both of them in it, y and x, okay? So what is the line that's perpendicular to this? Well, this is where we have to have a fact memorized that we learned. The slope of this line, right? This line's slope is 4. Do you remember what the perpendicular slope is? We use this little symbol sometimes for perpendicular. Perpendicular slope is the negative reciprocal. I'm just going to write neg reciprocal here, all right? What does that mean? It means you flip it and you put a negative in front of it. So our slope is the negative reciprocal of that one's slope. So our slope is negative 1/4. Why? Because it's perpendicular, right? Perpendicular lines have slopes that are negative reciprocals. So now we know our slope. So I'm going to start with this. Y equals negative 1/4 x plus b. I'm not going to use this negative 5 here. It doesn't say it has the same y-intercept, so that's useless to me, okay? But it does say it passes through this point, so we can replace the x and y by substituting in 3, 2. So let's make y 2, let's make x 3, and let's solve for RB of our line, right? Not that negative 5. Okay, so 3 times negative 1/4 is negative 3/4. Okay, we got a fraction, no big deal. Let's add it to the other side. There we go. And we need a common denominator. Well, that's 2 over 1, right? So why don't I just times it by 4, times the numerator by 4, and we're going to get 8 over 4 plus 3 over 4, and our b is 11/4, 11 over 4. So again, that would be, a slightly difficult one to graph. It's a decimal. We'd have to go, what's 11 divided by 4? But we're not looking to graph that right now. So there you go, 11 over 4. So what's the equation? Replace the m and b with negative 1/4, and then x plus 11 over 4. And there you go. So a lot of these lines, other than the special cases, notice they're all following the same pattern. You need two things. Step 1, what's the slope? Right? Once you got the slope, they all seem to follow the same pattern. Sub in the slope, sub in a point, solve for b. This one's trick was they didn't tell us the slope right out. They being me, I guess, want you to recognize and see if you understand what makes lines perpendicular, that the slopes are negative reciprocals. So you steal the slope and you change it into the negative reciprocal, and that's your slope. All right, let's move on to the next one. Okay, so like I was saying in the previous example, to find the equation, you need two things. You need slope and a point. So they didn't give us the slope, but they told us our line is parallel to this line. So parallel lines have the same slopes. This is this line's slope. This line's slope is negative 2/3, right? Now, what's the y-intercept of this line? There isn't one, right? Because it's plus 0. There's nothing there. But we don't care. It doesn't say it has the same y-intercept, so that doesn't matter to us. Let's get back to the slope. Parallel lines have the same slope. So the parallel slope, and that's what those two slashes mean, would be the same thing. So that's our slope. Our slope is negative 2/3 because our line is parallel to that line. Now, normally what you do is you'd sub in the slope, sub in the point, solve for b like usual. But look, they gave us a shortcut, right? The x is 0. That means this is our y-intercept, right? It crosses the y-axis at negative 12. So we can use that shortcut there. B is negative 12. Look, we're done this one. So looking out for those shortcuts and knowing they're there make life a lot easier. Now again, if you forgot or didn't remember, you'd go through your usual business. You'd sub in the slope, which is negative 2/3. You'd sub in the point, right? You'd make x, let's see here, you'd sub in, my bad, 0, negative 12. You'd make x 0, you'd make y negative 12. Negative 12 equals negative 2/3 times 0 plus b. And what do you end up getting? The negative 2/3 times 0, that's all 0. So it's 0 plus b, which is just b. So you get the same answer anyways, right? So maybe it takes you a couple extra steps, but you still got the same answer. But feel free to take the shortcut. If you recognize that, boom, you're done. The end. Okay, the next one, they didn't give us the slope at all. They didn't give us the slope. They didn't tell us our line's parallel, which means the slope's the same. They didn't tell us our line's perpendicular, which means the slope's a negative reciprocal. It's not a special case. They just gave us 2 points. So what do we do when we're given 2 points? We have to use the slope formula. The slope formula is y2 minus y1 over x2 minus x1. So label your points appropriately. Doesn't matter who's the 1s or 2s. I'm just going to go, I always go x1, y1, x2, y2. All right, so let's sub those numbers into our formula, right? Now be careful of double negatives. I don't think we have any in this case. y2 is -4 minus y1 is 7. x2 is 0 minus x1 is 6. So we got -4 minus 7, which gives us -11 over -6, which we can reduce our slope to 11 over 6 because the 2 negatives will cancel out. All right, so 11/6 is my slope. Now, what do we normally do? You sub in the slope, you sub in the point, solve for b. But again, I gave you a shortcut, right? If any of your points, right, if the x-coordinate is 0, b is automatically the y-coordinate. So the x-coordinate is 0, right? Anytime we have that, that's the y-intercept. This is not going to be the case with every question, but it pops up a lot. So cool, great. So b is -4. So there you go. I didn't even have to sub in a point and solve, right? So we get y equals 11 over 6x minus 4. Now, if you weren't given the y-intercept, if you weren't given the shortcut, you'd have to sub in one of these 2 points and solve for b. And I think we're going to run into that in the next question. Okay, here we go again like the last question. We got 2 sets of points. So we're going to use our slope formula, y2 minus y1 over x2 minus x1. All right, so it doesn't matter, like I said, who goes first, but I always just go x1, y1, x2, y2. All right, so let's sub those in here. All right, so we have -1 minus -1 over 7 minus 5. All right, so -1 minus -1 is -1 plus 1, so it's 0 over 2. Well, 0 over 2 is just 0, so our slope is 0. Now at this point, hopefully a bell's going off in your head if you've been doing all your homework. This is a special case, right? Anytime we have a slope of 0, what kind of line has a slope of 0, right? Think about steepness. What kind of line, if you were talking about steepness, what would that line look like? It would be horizontal, right? So let me just draw a quick horizontal here, right? That's what it looked like. Think about it. We got a horizontal line where 5 over, right? 5 over, 1 down, 7 over, 1 down, right? These points are creating a horizontal line. So how do we write the equation of a horizontal line? All we got to do is just write y equals the y-coordinate. They have the same y-coordinate. That's it. Y equals -1. What's the y-intercept? It's also going to be -1, okay? So horizontal lines, we can kind of just stop and be done. Now, let's say you didn't notice. Again, you could just continue on doing the same biz. Y equals mx plus b. All right, I'm going to sub in my slope, right? 0x plus b. Well, what's 0 times x, right? It's 0. So it's just y equals b. Well, sub in a point, what's b going to be? It doesn't matter. It's going to be one of these numbers, right? So it's going to end up being, when I sub in 5, -1, or 7 and -1, it's going to be y. The y-coordinate is -1, right? Y is -1. So there you go. Now, another way to spot this right away is if you notice that the 2 y-coordinates are the same. That right there, you could do no work and recognize, oh, this is a horizontal line. Cool. You don't have to show anything. You're done. And conversely, yeah. The x-coordinates, if they were the same, that would be a vertical line, right? And we could just write x equals whatever that coordinate is. All right, let's move on to the next one. Okay, here we go again. Doesn't look like we have a special case, right? Because now we know to check for that. Are the x's the same? Nope. Are the y's the same? Nope. So this is not a special case, so we can't do a shortcut there. We're just going to have to do the usual biz where we go x1, y1, x2, y2, right? And let's do our slope formula. y2 minus y1 over x2 minus x1. This is, again, for those of you who are going to grade 10 academic and who are honestly interested in pursuing math, at a higher level, you got to know this formula, okay? So here we go. -11 minus 2 and -7 minus -5. We got a double negative there, right? So we got -13 over -7 plus 5, which gives me -2. And we can cancel out the 2 negatives there and just make it 13 halves. There you go, 13 over 2. Okay, 13 over 2 is my slope. All right, so there's no shortcut here. The x-coordinates aren't 0, so I don't have my y-intercept. It's not a special case. There's nothing I can do. So what do? Do the same thing I did in most of the other questions. I start by taking y equals mx plus b. I'm going to sub in my slope, which is 13 over 2. And then we're going to pick one of these 2 points to sub in. It's up to us. We get to choose. So I'm going to choose what looks like the easier one. I'm going to sub in that guy. Substitute in -5, 2. So we're going to make x -5, y 2. So here we go. 2 equals 13 over 2 times -5 plus b. All right, so let's go. Well, what's 13 times -5? Which is -65 over 2. There we go. All right, so we just got to solve for b. So it's just a fraction. Let's get to the other side. So now we have 2 plus 65 over 2. And we just need a common denominator. So let's make that 2 over 1. What are we going to do? Times the bottom by 2, the denominator, times the top by 2 to get a common denominator. So we got 4 over 2 plus 65 over 2. And I'm running out of room here. So we get b equals 65 plus 4. We got 69 over 2. So there you go. Again, it's just an messy decimal number, but that's okay. We want to leave it as a fraction. Y equals 13 halves x plus 69 halves. All right, so there you go. And again, that's generally what happens with a lot of these questions. You find your slope, you take one of the points, you sub it in, you solve for b. All right, let's move on to the next. All right, so this next one says it has an x-intercept of 2 and a y-intercept of 6. So what do we got to recognize? The x-intercept and y-intercept are just points. The x-intercept is when x is 2 and the y-coordinate is 0. The y-intercept is when the x-coordinate is 0 and the y-coordinate is 6, okay? So again, if you forget that, go back and watch the video talking about intercepts, right? They're just points. It's just to short form it, instead of writing the entire point out, they just tell you the key coordinate, right? The x-intercept or the y-intercept's key coordinate, okay? So this is where the line crosses the x-axis and the y-axis. So guess what? We got 2 points. What are we gonna do? x1, y1, x2, y2. The first thing we always have to find is our slope, so let's use our slope formula, right? Unless it's a special case, I gotta start by finding my slope. All right, so what do we got here? 6 minus 0, y2 minus y1, and 0 minus 2, x2 minus x1. So we got 6 over -2, not 2, right? And then 6 divided by -2 gives me -3. All right, so there's my slope, -3. Now I got a shortcut here. What's the y-intercept? They gave it to me. I'm not gonna waste my time subbing in a point. It says it right there. The y-intercept is 6. We just wrote it as a point. There it is. It's 6. Cool, so I'm done. Y equals -3x plus 6. Right, now again, a lot of these seem like they're totally different from each other. It's the same idea. I'm just kind of going through all the different scenarios and little bumps you can run into. Maybe you're given the parallel or perpendicular line, maybe you're given the intercepts, and trying to show you that it's all kind of the same thing and where can you find shortcuts to speed it up. All right, a couple more, about 3 more left. All right, this next one says your line is perpendicular to 5x minus y plus 7. Perpendicular means the slopes are negative reciprocals, but I have no idea what the slope is of that line. So what we need to do, look at this, let me write it out a little neater, like that. That's in standard form, so we need to put it into y equals mx plus b form. So you know what I'm going to do? I'm going to leave the negative y on this side, move the 5x over by subtracting 5x, subtract 7 from both sides, there we go. And then I'm going to divide both sides by -1, because we don't want to know what negative y is, just what y is. So y equals positive 5x plus 7. Now, what's the slope of that line? The slope of that line is 5. What's the perpendicular slope? Perpendicular slopes are negative reciprocals. So the perpendicular slope, we need to flip that, make it 1 over 5, and put a negative in front. So it's -1/5. So the slope of our line is -1/5. That's all we're allowed to steal from that, right? Because we know our line is perpendicular to that line. So we find its slope by rearranging the equation, and then we flip it. So we saw one of these earlier, except we didn't have to rearrange in that case. All right, and it says it has the same y-intercept as this line. Okay, so this line's got the same problem. It's in standard form. We need to rearrange it so that it is in slope y-intercept form. So let's isolate the y term, subtract 7x, add 15 to both sides, and then divide both sides by 3. All right, divide this side by 3, divide this side by 3. So we have y equals -7/3 x plus 5. Now, we're not concerned about the slope. It says it has the same y-intercept. What's the y-intercept of this line? It's 5. So what's the y-intercept of our line? 5, because it shares the same y-intercept. So we're kind of doing a Frankenstein equation here. We're stealing a piece from one equation, we're stealing a piece from the other equation, and now we're going to put them together to make the equation that it wants us to make, which has the perpendicular slope of the one and the same y-intercept as the other. And there you go. All right, 2 more left. All right, this is the one that probably is going to take the most amount of work. It's not that much more than the previous ones, but a little more. All right, so first let's deal with the fact that our line is parallel to this line. Parallel means it has the same slope. So we need to find the slope of this line. But again, it's not in y equals mx plus b form. So you have to convert it. You have to know you got to convert to that form. So let's leave the negative 2y on this side. Let's subtract 3x. Let's add 1. And let's divide both sides by negative 2. So we're going to divide each term by negative 2. And we get y equals 3/2 x minus 1/2. Now again, it is parallel, so the slopes are the same. So the slope of this line is 3/2. The slope, the parallel slope of our line is also 3/2. Okay, so that's our slope. So I'm going to write that over here. There's our slope, 3/2. Cool, so we got the first piece of information. Now it says it has the same x-intercept. Now that's not the y-intercept, so that's not b, and that's what throws everyone off, okay? That's what makes this question, I guess, the most challenging is that. You got to find the x-intercept. So the first thing is, how do we find an x-intercept? That was in a previous lesson. To find the x-intercept of a line, right, that's the place where it crosses the x-axis at. And when it crosses the x-axis, the y-coordinate is 0. We need to figure out what the x-coordinate is. So we already know the x-intercept always has the y-coordinate be 0. We just got to figure out x. So what do? We substitute into the equation y equals 0, and we solve for x. And again, we covered that in a previous lesson, right? So there's a lot to go back and review, right? Very, very important unit, okay? All right, so let's do that. So I'm going to take this equation. I'm not even going to bother rearranging at this point. All I really need to know is figure out what x is. So when we make y 0, I'm replacing the y here, right? This y was 0. Let's solve for x. Oops, and I forgot the equals 0 there. Okay, so negative 9 times 0, that's 0. It's gone. So what's left on this side? 7x plus 21 equals 0. All right, so what are we going to do? Subtract 21. 7x equals negative 21. And then divide both sides by 7, and you get x equals negative 3. Now, what is the point? Think back to the start here. What did we just say? When y is 0, what's x? We just found out. The answer is x is negative 3. So it's negative 3, 0. All right, now this is where people get stuck. A lot of people go over here and go, oh, so b is negative 3, right? No, that's why this is one of the bigger questions. All right, so let's think. What do we have right now? We have the slope. Check, right? We found that. We found the x-intercept. What's the x-intercept? It's a point, right? It's not the y-intercept, but it's a point on our line. Check. So we know that point's on our line. We know that's the slope. Let's put those two pieces of information together. Let me just, carve out a little space here. Let's put them together into y equals mx plus b. All right, so let's sub in our slope, which is 3/2, and let's sub in that point. Let's substitute in negative 3, 0. Make x negative 3, make y. All right, so let's do that. 0 equals 3/2 times negative 3 plus b. So all I'm doing is I have a point, right? That's all the x-intercept is really useful to me in this scenario. It's not the y-intercept, but it is a point on my line. So I'm going to use it to find b, the y-intercept. All right, so 3 times negative 3 is negative 9 over 2. And all we got to do is add that to the other side. 9/2 is b. We just did it. There you go. So b is 9/2. All right, so our equation is y equals 3/2 x plus 9/2. So again, that's probably our busiest one, and kind of that's the challenge one. Like if this, all these questions are normally on a test. This is generally like your big test is doing each of these questions plus some graphing stuff, okay? So this is, the key stuff you really got to know. And this is generally the challenger question, right? All right, let's do one more and then we're done. Okay, final example here, example N. Let's find the equation of a line that passes through these 2 points. And then as soon as people see this, they just panic. They say, I can't do this. Look, everything's a fraction, right? But we have 2 sets of points. What do when we have 2 sets of points? x1, y1, x2, y2, and we're going to use our slope formula. Now, I've set this up for those of you that are brave and just work your way through it. You should find it actually works out to be really nice. All right, so what do we have here on top? Negative 1/2 minus, that's y2 minus y1, which is negative 2/5, so I have a double negative, divided by 6/3 minus 3/4. All right, maybe a little messier than I thought, actually. Let's see how this turns out. I thought it was going to be really nice, but maybe it still will. On top and bottom, we have to get common denominators, right? So what's a common denominator for 2 and 5? How about 10, right? So I'm going to make the common denominator 10 on my top. So this is going to be negative something over 10, and these 2 negatives are going to make a positive, plus something over 10. So we're going to times 2 by 5, so 1 by 5 is 5. Oops. And 5 times 2, so 2 times 2. All right, let's look at the bottom here. On the bottom, we need to get a common denominator for 3 and 4. Well, how about 12, right? So this is going to be over 12 minus over 12. All right, we're going to have times 3 by 4, so 6 times 4 is 24. And we have times 4 by 3, so 3 times 3 is 9. All right, so let's finish the top. Negative 5 over 10 plus 4 over 10 gives me negative 1 over 10. 24 over 12 minus 9 over 12. What are we going to get? 15 over 12, right? Okay, I think I lied. I thought this was going to work out nicer. It's pretty ugly, but we're not done. How do we divide fractions? People, even those who are brave, get to this point and you go, oh, I don't know what to do. Well, why don't we write it a different way? Instead of writing as one giant fraction, we could write it like this: negative 1 over 10 divided by 15 over 12. And some of you might be thinking, hey, I'm going to reduce that 15 over 12. That's a good idea too. Now, how do we divide fractions? We're just going to flip and multiply by the reciprocal. Not the negative reciprocal, just the reciprocal, right? That's how we divide. All right, so let's do a little reducing here. 10 and 12, I can divide those both by 2 and make that into a 5 and make that into a 6. And 6 and 15, I can divide those both by 3 and make that a 2 and make that a 5. And let's multiply what we got left. Our slope is negative 2 times 1 is 2, 5 times 5 is 25, negative 2 over 25. All right, so that's a challenger, right? That's a real, do you really know your stuff? Are you looking to get that A, right? Okay, so we found the slope. Now, we got to find B. What are we going to do? The same thing we did before. Sub in the slope, sub in the point, and let's solve for B. All right, so there's my equation. Let's replace the M with negative 2 over 25 plus B. Oops, I forgot the X. And let's pick a point to sub in. Now, it's up to us. Do we want to do this one or do we want to do that one? It really doesn't matter. I'm going to go with the first point. All right, so we're going to substitute in 3/4 and negative 2/5, right? So let's sub that in here. So y is going to be negative 2/5 equals negative 2 over 25 times 3/4 plus b. Now I'm running out of room, so we're just going to bring this up here, okay? All right, so we have negative 2/5 equals, we're going to multiply these down here. But look, I can do a little reducing. 2 goes on itself once and goes on to 4 twice. That's all you can reduce, but it does help. Because on top, negative 1 times 3, we have negative 3, and 25 times 2 is 50. All right, we're going to have to move that to the other side. So now I have negative 2 over 5 plus 3 over 50. And we need a common denominator. Well, common denominator for 5 and 50 is 10, so not too bad. Let's times the top and bottom by 10, right? And we're going to end up with negative 20 over 50 plus 3 over 50. And negative 20 plus 50 is going to give us negative 17 over 50. And there's B. Not a pretty number, but if you can get a question like that solved, that's pretty good. That really shows you're ready for grade 10. All right, negative 2 over 25, x minus 17 over 50. All right, so that's it for these examples. Again, these are the questions that I would go through with you guys in class, that I would assign you for work, that we'd be really preparing for the test, saying, all right, this sums up all the different skills that we use to find the equation of a line. And I generally go through exactly these, and then when I give you a test, I say, all right, you're going to have to do the exact same thing, just some different numbers, okay? So try the homework, and when you do the homework, follow along with these. I'm going to put them in the same order with the same skills, and you can use the same skills in the same order, okay? So watch the video, pause the video as you go, that kind of thing. All right, and don't be afraid to ask questions on Edsby, and I'll talk to you guys later.